Good afternoon, my YouTube viewers. It is Crystal here, and I want to give you another code review. And this code review that I'm going to be giving you is going to be on the Flax library using the Boston house prices. Now, what Flax is Flax is a library that's written on top of JAX, and Flax enables you to create neural networks with JAX. And so in my previous videos, I discussed JAX and I discussed how JAX was similar to the NumPy API, but does a lot more than the NumPy API. And then so I also did a lot of videos with JAX. Well, now I'm going to be studying Flax, and I'm going to be creating videos on Flax. So Flax is written on top of JAX to help you to create neural networks. And we're going to be using the Boston house prices to make predictions. And so what we're going to do is, the first thing we're going to do is we're going to import our libraries. So the first library that we're going to import is JAX, because you need JAX in order to use Flax. Then we're going to import pandas, and pandas is going to create data frames and process data. From typing, you're going to import sequence and tuple, and then we're going to import Flax, which is the library that we're going to be using. From Flax, import Linen. That's going to be your neural network. We're going to import OptX, which gives you your optimization, and it's a separate library because when I was doing my studying code, they said that Flax originally, or JAX originally, had OptX in it, and now that is deprecated, and they're using the OptX library instead. We're going to import sklearn to give you your machine learning functionality. We're going to import Seaborn to help you to statistically visualize the documents, and then we're going to import Matplotlib to visualize the documents as well. So after we've imported our libraries, what we're going to do is we're going to load the CSV file, which I got off of Jason Brownlee's site, and it's going to be the Boston house prices, and we're loading his CSV file because you can no longer find Boston house prices on sklearn, and I believe it's because they had a column about deprived people, and then they had a column about blacks, and I think that because of the column about deprived people and the column about blacks, they decided in their woke mentality to do away with the data set. But the problem is, even though sklearn has taken the Boston house prices off of their site, they haven't replaced it with anything. For instance, if they wanted to replace it with California house price data set, they could do that, but they haven't. And so we define our X variable as being all of the columns and rows except the last one, and they define the Y variable as being they define the X variable as being all of the rows and columns except the last one, and they define the Y variable as being all of the rows and the last columns. And it's being a bit awkward here, so I'm going to rerun it. I don't know what's happened to it, but I'm just going to rerun it. I'm going to take just a little bit of time to rerun it. Okay, so it's running. So you can see what the data set looks like. And then we're going to set the seed as being jax.random.prng key 42 because the guy who wrote Hitchhiker's Guide to the Universe or to the galaxy said that the answer to everything is 42. And since the answer to everything is 42, I thought, well, that's a good key, a good seed. And then we're going to create the box plot. And so when we create the box plot, you can see that we do not have any columns that are highly correlated. And then so now what we're going to do is we're going to convert the arrays into JAX arrays. So x equals jmp.array x, y equals jmp.array y. And now we're going to scale the data because the data needs to be scaled. Mean x equals x dot mean, and std x equals x dot std. X equals x minus mean x over std x. So now what we're going to do is you're going to analyze the target, and so you can see that this is the target, your y variable, which is the median house price, and you can see that there are some outliers in that target. Now what we're going to do is we're going to split the data set into training and testing sets, and we're going to use sklearned train test split to accomplish that. And now what we're going to do is we're going to define our MLPRegressor from Flax. It's a Flax regressor. So class multi-layer perceptron regressor and brackets linen.module. So features a sequence integer 5, 10, 15, 1. I've never really used this code a lot. I'm still just learning how to use it, but your 5, 10, 15, and 1 are going to be your weights and your biases. Def setup self.layers equals linen.dense feet for feet and self.features. And def call, it's going to be self inputs, x equals inputs for I, layer, and enumerate self.layers, colon, x equals layer x. If I is not equal to len.self.layers, -1, x equals linen.relu x, return x. And relu is an optimizer in neural networks. It's not an optimizer, it's an activation function in neural networks. Okay, so now what we're going to do is we're going to define a module, a function, def mean squared error loss. So it's going to accept weights, input data, and actual. Preds equals model.apply weights, input data, return jmp.power, actual minus preds.squeeze, and then comma 2 brackets dot mean. That's what it's going to return. And now what we're going to do is we're going to train the model. And so where I had some difficulties with another data set, which I'm going to do in another video. So you have lots of optimizers that you can use to actually train the data. So if you want to come over here to the Optex, if you come over here to Optex, then you can see that this is the library that we're going to be using, which I'm going to be studying Optex a lot. So I can learn Optex, because JAX and Flax don't use their own internally generated Optex anymore. They use this library. And then so if you want to find out the common optimizers, it tells you the optimizers, which Atom, I think, is one of the most common optimizers, but they decided to use SGD. And it worked. When they used SGD, it worked. But another optimizer that I've used in the past is RMS prop. So we're going to set it up for 5,000 epochs model equals multi-layer perceptron regressor, and then random ARR equals jax.random.normal, brackets key equals seed, shape equals 5, features. So it's making a random array with 5, features. So I believe that's 5 rows, and then the number of features. Params equals model.init, bracket seed, random ARR. So it's going to initialize the parameters. So optimizer equals optext.std, so they use the std optimizer. Learning rate equals 1/1e3, and then it says optimizer state equals optimizer.init params. So init is initialize. Loss grad equals grad.value and loss grad equals jax.value and grad mean squared error loss. And then now it's going to put it into a for loop to train the data into the model for I in range, brackets I, epochs plus 1. Val loss equals gradients. Val loss, gradients equals loss grad, brackets params, x train, y train. RMSC equals JMP dot square root loss val. Updates optimizer state equals optimizer update gradients optimizer state. Params equals optext dot apply updates. Params, updates and update weights. If I divided by 100 does not equal 0 or does equal 0, print RMSC, and that's the number of epochs plus RMSC. So we printed all of our epochs. We've got 5,000 epochs that went through the 5,000 epochs while I was going over the code. And now we're going to make predictions. Test preds equals model.apply params, x test. And then test preds. So we're making predictions on the test data set. And we're going to evaluate the test set, and its R squared score is negative 0.37, and we'll say R to the power of 2, coefficient of determination. In statistics, the coefficient of determination, denoted R squared and pronounced R squared, is the proportion of the variation. And it says, what does R squared tell you? The R squared, or the coefficient of determination, is a statistical measure in a regression model that determines the proportion of variance in the dependent variable that can be explained by the independent variable. In other words, R squared shows how well the data fits the regression model. So it's a goodness of fit test. And so R squared score is negative 0.37. Now we're going to check the root mean squared error, which is the metric that I prefer to use, and it's 10.34. And then we use Seaborn to analyze the prediction, and so you can see that the prediction is close to a normal distribution. And now what we're going to do is we're going to plot that using Matplotlib, plot it onto a graph so you can see what it looks like on a graph. Now we're going to compare it with sklearn, and we're going to use sklearn's MLPRegressor, and the root mean squared error is 7.2. So you can see the root mean squared error using sklearn is 7.23, which is about 2.5 points better than this neural network that we have made in Flax. But what you can do is you can experiment with different optimizers to find out which one will do the best. And then we plot the actual values onto the linear line the the regression line, and you can see there's a plot of the values. So you can see sklearn performed better than Flax in this particular instance. But you can change your optimizer to use like a different optimizer, and you can change your learning rate to see if you can improve the score. And this is the first time I've done MLPR in Flax, so I'm going to be doing a video for you on another MLPR with a different optimizer, and so you can see the difference. But you can experiment with different optimizers and learning rates to see if you can improve the score. So what I'm going to do is, since we've done the code review, what I'm going to do is I'm going to go ahead and conclude this video because I've talked about everything that I want to talk about. And as I learn more about Flax, I will become more proficient in this library, which, as I've said, is written on top of chunks. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching the video, and I look forward to making more videos for you in the future.